Productizing a codebase. This is part of Get It Right in Black and White, but it's a little different because it's just me working on this stuff. And this is work I was going to do anyway, so why not put it in the series? This work is about exporting something that you built in VizHub out of VizHub, putting it into a GitHub repository, which is where people, generally put code, and deploying it with GitHub Pages. Also, this particular work happens to do some data processing in Node.js, so we'll touch upon that as well. This is the thing that I built. It's a stream graph of D3 activity for the past 10 years. I'm not going to talk at all about how this works, but think of it as a black box code base that we're going to get out of VizHub and sort of productize, make it a real open source product. I'll start by exporting these files, and we get this zip file that has a bunch of files in it. But where should we put this stuff? We should put it in a Git repository. Let's make one of those. In GitHub, I'm going to click on this little plus and create new repository. I'll call it something like Git history stream graph. I'll make it public, add a README, choose a license, I'll make it MIT. Create repository. All right, we've got this empty repository. I'm going to copy this text so that in our terminal, we can go to where the repositories are and use Git Clone and paste that URL to clone that down. Whoops, the directory already exists. Let me try that again. And now it's working. I'm in a Linux terminal, by the way. This is my typical working environment. Git is installed. You might have to stop and install Git on your machine. RM means remove. The -F means force, and the -R means recursive. And git clone is the command that you use to make a copy of all the stuff in the Git repository on your machine. Now that that's there, we can cd into that directory. cd means change directory, and then ls, meaning list all the files there. And I like to use Vim as my editor with nerd tree that lets you see all the files. So this license is a MIT template, and this README is a blank README. I think I'll start this work by just referencing all the input sources in the README. This project aims to visualize Git history as stream graphs. It draws from the following previous work, namely, and this is where I'll drop a link to this thing here, D3 Git history stream graph. And I'll make that a link in Markdown that goes to that URL. This one here, I'll copy it and paste it right in there. And this one refers to this thing that's in GitHub Gist right now, which is a set of Node scripts that are forked from original work by Ian Johnson. He actually figured out how to do this, how to get the data of commits out of a Git repository and into a CSV file. So I'll link to this one as well. Ian Johnson's set of scripts to pull the Git history. And I'll make that a link to this URL right here. Okay, I'm going to write the file and quit Vim, and now I'm going to make the first commit. Git status -s is how you see what the status is. Git diff is how you can tell what changed. Git add makes sure that all the changes you made are sort of staged to be added to a commit. And then git commit -m, add links to README. and then finally git push. Git push will push up the changes that you made into the repository in GitHub. So back in GitHub, if we refresh the page, we should see this new stuff. The language of the README file, by the way, is Markdown. It renders to HTML and looks like this. So now you see these are links, but in the original text, you know, this big heading is just a hash, and you can make the bulleted list with these asterisks. All right, now that we've got this far, I'm going to start by pulling in those node scripts, and then after that's done, we'll pull in the front-end code that makes the visualization. Here's my fork of Ian Johnson's gist, which has been modified to remove bulky commit message data and to also publish the combined file to a gist. And by the way, that stream graph thing, it pulls the data from this gist. To add these files to the Git repository, I'm going to start by cloning this gist. I'm going to clone it as a peer directory with git clone, and then I'll paste that URL for the gist. Okay, it's already there on my machine. I'll just do a git pull to make sure I have the latest, and I do. Okay, so we have a bunch of files here. The main things I'm interested in are these JavaScript files. So I'm just going to say copy everything that ends with JS over to our Git history stream graph directory. Then I'll go back to that directory, take a look. Okay, everything moved over. At this point, I know we're going to have a bunch of files eventually, so I want to start to organize them. These files are the data processing scripts, which will be, I think, in a different directory than like the front-end code, so I'm going to make that directory now. I'm going to make a new directory called data processing scripts, and then I'll move over all those JavaScript files into that directory. Now our directory looks something like this, where we have a bunch of JavaScript files and a README and a license at the top level. At this point, I'll make another commit. Oh, before that, I have to add all these files. And then I'll make a commit that says add data processing scripts. At this point, the main focus is just to get all the code into the repository. So I'm not even going to run these scripts. I'm going to refactor and massage that stuff later. But for now, the goal is to get the Viz running and publish it with GitHub Pages. To that end, I'm going to extract the stuff from our zip file, our VizHub export, into this directory by clicking on extract and navigating to that directory. And I think I'll make a new directory called VizHub export, just to keep everything totally separate for now. I'll hit extract, show the files, and there they are. Okay, great. Now we have our VizHub export. I'll make a commit. But first I have to write git add. Okay, I'll push this up. Now that everything is there, we should just be able to turn on GitHub Pages and get that whole hosting working. For that, I can go back to the repository, which now contains VizHub export, and inside there's an index.html that should work if we just host it with GitHub Pages, which we can enable in the settings of the repository. We can just scroll down and find Pages, By default, it's disabled, but we can just turn it on and say, all right, host the main branch at the root, and click Save. Now it says your site is ready to be published at this URL here. And now we just need to modify that path to go to /VizHub export /index.html, I think. If I just paste that in, it's going to work. Not quite yet. It says the site is currently being built. I guess it might take some time. Okay, I just refreshed, and boom, there it is. All right, that's how you can export something out of VizHub and put it into a GitHub repository and then enable hosting with GitHub Pages. From here on out, I'm just going to massage this code base to be coherent and clean. And also make it so that the Viz pulls the data from the repository as it gets generated in this repository. The first thing I'm going to focus on is whipping these Node scripts into shape. Currently, they're kind of a mess. They create GitHub repository. They create Git repositories as peers of the source files, which is not quite right. So if I open up the editor, go into data processing scripts, there's a bunch of different scripts that do different things. This one clones all the D3 repositories from dependencies. And then you run this knife SV thing that generates a bunch of files, JSON, which converts those files to JSON, and then combine, which combines all of those together into a single file. Ideally, we would just have one script that we could run. So let me start there and see where it goes. I'll make a new file called index.js under data processing scripts. And this will be the main thing that runs. So first we clone the repositories, convert to knife SV files, convert to JSON files, and combine the output file. Since this is Node, I'm just going to use require rather than import. If we say require /clone, that should pull in the stuff from this clone file over here. I'll call it clone when we import it. But the thing is, this is currently a script that runs. So instead of just running a script, I'm going to define a function called clone, which is a function that just goes through each of the dependencies and clones them. And then in Node, we can export it by saying module.exports equals clone. Now we can just proof that this is working by saying console.log clone. It should output a function. And then I'll make a new terminal window here, navigate to the data processing scripts directory, and then run it. Node index.js. Okay, it's looking for D3's package.json. Yeah, those scripts assume that the D3 repository is cloned, but that's not really the case. So I'm just going to take this package.json and drop it into our repository. I'll call it d3 package.json. Create that file, paste the content, and then I believe it's this depends thing that is pulling in that file. Let's change this path to be d3 package.json and see if it works now. Okay, it worked. We got a function. Great. Now, this clone function itself just runs git clone, and so you know, I'm not even sure where these would end up. Well, let's run it and find out. In index.js, we can actually run that function. So when I run this, it's doing a bunch of stuff. I'm going to stop it before it gets too far. And now, see, there are all these D3 repositories right here in the same directory as all the source files, which is kind of a mess. So I'm just going to delete all those, remove everything that starts with D3 dash, because I want to keep D3 package.json. Okay, now those are all gone. I think the best approach might be to have this clone script make like a directory. We can run exec outside of all that and have the command be make directory repositories. And we could handle errors here, but I don't think we really need to. And then we would cd into repositories and then run git clone on all this stuff. Let's see if that works. I'll run node index again. And then again, I'll stop it with Control C. Huh, it did not work. It did create the repositories directory though. I guess the CD didn't work. Yeah, it looks like it doesn't work for CD. It looks like we can pass something into exec called cwd. Let's try that. So instead of CD repositories, we just pass an object with cwd / repositories. Would that work? I'll get rid of those D3 things again. And then see what's in repositories. Okay, it worked. Look at that. All the stuff has been cloned into repositories. Excellent. Okay, at this point I'll make a commit. Oh, you've added another Git repository inside. Yeah, you know, I think we just want to totally ignore that directory, which we can do by editing .git ignore. If I just put that in git ignore. Okay, it still added them. But let me just remove that whole thing. Okay, now if I go and run that thing again, it's going to clone all the repositories. Now when I do git add, it doesn't catch them. But I think they are still there. Yep. Okay, so git ignore is working. Now I'm going to make a commit that says start iterating data processing script. One thing I don't like about this is when you run it, it doesn't even tell you what it's doing or how far along it is. So I'm just going to add a little something that says console.log command, just so we know which command is running. Also, we may as well output the error, just so we know if anything happens. Or rather, if there's no error, error is null. So let's say if error, then console.log error. Okay, now we get some stuff. Git clone fails when it already exists. Okay, yeah, that makes sense. So let me remove that repositories directory and try again. Okay, it's running all this stuff. And it finished. Amazing. So if we run that again, it's going to give us all this these errors. But I think I wanted to actually just not tell us if there's an error, because I could imagine, you know, running this index again and again. And if it's already cloned, you know, it's already cloned. So now let's work on the knife aspect. Just copy that line. Change all clone to knife. And then we just run knife. But over in knife, we need to again make an exported function. So I'll make a function called knife that runs this command and then add it to module.exports. Module.exports is knife. Now if we run this whole thing, oh, it's trying to CD into the repositories, but it's looking at the wrong place. So instead of CD repo, it should be CD repositories / repo. Let's try that. Cannot create / data / d3. Okay, that makes sense because we don't have a data directory. Similar to clone, we might want to make a directory. Make directory data. So now let's try it. Okay, that did not work. I think we need to be going .. / because here we go 2 levels down, not 1. So let me try that. .. Okay, it's working. And we're getting all these nulls because it's doing console.log error. I'm going to change it to only console.log the error if there is an error that's not null. Okay, now it runs fine. Now let's run the Json conversion, which we can get from that file. Replace knife with JSON. And in JSON, we can say const JSON equals a function. that runs all this stuff. And then export that. Let's see if that works. It seems to have worked, but I don't really like how we don't know what it's doing. So I'm going to add a little bit of console.log cloning ... knifing ... converting to JSON ... That's a little more user-friendly. I sort of know what's happening. And lastly, we need to combine the output file ... So we can run combine, which we get from combine.js. And here again, we need to make this a function that runs all this code here. And then export it like that. All right, let's see if it works. Okay, that looks good. We've got this new file, all D3 commits, which looks something like that. And you know, I'm always a bit hesitant to add data to repositories because the files are usually pretty big. And in the case of this one, there is actually further aggregation that happens in the front end. It actually aggregates by week. Yeah, with some stuff from D3, UTC week. And then it applies some smoothing to that data. But, you know, the smoothing, I kind of want to keep that on the front end so that if we wanted to, we could vary how the smoothing is done. But I think it would be advantageous to do this data processing in the Node script so that we don't have to fetch a 500 kilobyte file. We can fetch a much smaller file that just has the weekly aggregations. And then we wouldn't need to add this data file to the Git repository at all. In our data processing script, we can add another step, aggregate by week. I'll call it aggregate, and we can get that from aggregate.js, which is a totally new file, which will have a function called aggregate, and that will be exported. This is where we get to do the fun exercise of porting browser-based code into Node. This code here expects data as the output from the previous script in this pipeline. Namely this file here, all D3 commits. So let's load that file here with fs.read file sync all D3 commits .json, and we can call that data string, and then data would be json.parse data string. And then let's console.log data just to see if it worked. Oh, fs is not defined. Fair enough. I'll look at some of these other scripts. It just requires fs, which is the built-in Node file system module. And it looks like we might need a .toString on the result from read file sync. But if we run it without that, it actually works just fine. So maybe we don't need that after all. Okay, we've loaded in this data. Now we can take the stuff out of VizHub that processes this data. I'm going to copy all this code up until the place where it computes layer data. And what we're calling layer data here, I think, will be the output. It's the aggregated data. So I'll paste all that stuff in here. This code imports a bunch of stuff from D3, but since we're in Node, we can say const D3 equals require D3. And for that to work, in our data processing scripts, we really probably should have a package.json to track our dependencies like D3. To create a package.json, I'm going to run npm init. And I'll just, accept all the defaults. And then we can run npm install -s, meaning update package.json, D3. And if we take a look at package.json, this is how it looks. That's fine. Main thing is it has the dependencies now. That means that this line of code here will work. We can reconcile this ES6 import syntax with our ES5 node environment by saying const all this stuff equals D3. This is destructuring right here. And I might as well move that up to where it's imported. Okay, so let's organize this code here. We've got parse date and layer, which are statically defined. So I'll pull those out. Transform data equals data. Well, we don't need that because we're already inside of a function that has data there visible. All this stuff should run just fine. And then down here is where it sort of trails off. We gotta just wrap it up here. And we have layer data, which we somehow need to get into a file. So let's see what layer data looks like here and see if the code runs to this point. So if I run index.js, apparently layer data is a big array. Probably the easiest thing to do would just be, make an object. I'll call it aggregated data. And layer here is the name of a layer. So I'm just going to say aggregated data at layer equals layer data. Now we have something that we can output to a JSON file. Let's see, how did that other module do it? There it is, fs.write file sync. So I'll just drop that line, and it calls json.stringify, and I'll just pass in aggregated data to there. And the file name, I think I'll just call it aggregated data.json. Now if I run everything, we have a new file called aggregated data.json. It contains a bunch of zeros, but I think that's okay. Each of these numbers corresponds to a week, but you wouldn't know that based on this data. In our code, the weeks are available here as all weeks. So let me just make that available here in aggregated data as all weeks. And then we can nest the repository data under, say, repositories. Now we can say aggregated data dot repositories add layer equals layer data. Let's try this. Okay, now we have all weeks. The format is a little verbose. I kind of want to just clean that up. We already have this parser, so let's just add a formatter. Format date is time format, and we need to get that out of D3 as well. Now, instead of all weeks, I think I'll call it dates, because, you know, we might want to use months or something in the future. And then we can say all weeks.map format date. Now when we run this, oh, we get an error. I'll just backtrack. Okay, now it works. I don't know what I broke or how I broke it. Just introducing the formatter shouldn't do anything. But it does? What? That's odd. If I don't create the formatter. I don't know. Twilight Zone moment. Okay, let's try it again. Okay, this is super weird. It says, you know, d.date is undefined if we do it like this. But if we do it like this, explicitly pass one thing into format date, then it works. Weird. Might be something about a second argument to format date or something. But anyway, now it's working just fine. Now if we take a look at the files, we can see that the aggregated data now is only 31 kilobytes instead of a whopping 426. We should just make sure that this data doesn't end up in the repository. So I'm going to delete this file. And I'm going to tweak this script to generate this inside of data, inside of the data directory. Data / all D3 commits. And then when we load that, we need to get it from the same place, data / all D3 commits. And then in our git ignore, we can also ignore the data directory so that everything in there does not end up inside the Git repository. So I'll run all that stuff one last time. Okay, it worked. If we do a git status, we see the stuff here generally looks good, but I see there are swap files being tracked. And also node modules is being tracked by Git. We don't want that, so let's go back to our git ignore and say any swap file. This is just a temporary thing that Vim generates that we don't need in Git. Also node modules. Okay, great. There we have it. We have aggregated data.json visible, which is only 30 kilobytes. So I feel good about adding all this stuff. And then I'll make a commit. Add aggregated data. Now that we've got the data processing scripts sorted out, let's deal with the front-end code. The front-end code is currently in this VizHub export thing, which has sort of a sketchy, dead simple package.json and rollup config. The first thing I want to do here is make sure that we have a proper setup. So I'm going to turn to Rollup Starter app. We can pull things in from here, and I like to do it one at a time. So here's package.json. Since the thrust of this project is the front end, I'm going to let the front end code live at the root of the repository. So I'll just drop that stuff into package.json. But instead of Rollup Starter app, we should call this Git History Stream Graph, like so. Everything else looks decent. I'm just not sure that it's at the latest version. Oh, and we don't need date functions. That's something that's used by, the starter app. I'm just not sure all this stuff would be at the latest version. So I'm going to run NCU, which is, you can get it with npm install -g npm check updates. This is a little utility that goes through your package.json and checks if all the versions are the latest. We can run it with NCU, and it turns out there's some version increments, and so I'm going to run NCU-U to actually modify package.json to use all the latest versions of things. And then I'll run npm install. While that runs, we can pull in some other stuff from this starter app, such as the rollup config. This is more of a production-oriented configuration for rollup. So I'll make a new file called rollup.config.js, and I will drop this content into there. Now let's look at our files and take what we need from the VizHub export. There are really only two main modules here, index.js and transform data. I'm inclined to make a new directory called src, the source directory, and put those files there. So I'll just move those into the source directory. And notice that the rollup config looks for src/main.js. I'll just change that to index.js. And index.js imports a lot of stuff from D3 and also from D3 area label. Now, this is a fork in the road where we could choose how we want to include our dependencies. We could either go the traditional route of pulling in the dependencies into our bundle, having a huge bundle with all of the functions from D3 and these libraries that we're using, or we could opt to pull our dependencies from a CDN like unpackage and have our bundle only contain our code and not any other library code. That's what I'm inclined to do because we're publishing this with GitHub Pages. And to publish this stuff with GitHub Pages, we need to include the bundle in the Git repository. And if we include a bundle in the Git repository that contains like D3 and libraries, it's going to bloat the Git history. So that's why at this juncture, I'm going to opt toward using libraries that come from a CDN. To do that, we need to adopt some of the stuff that's going on in the VizHub config for Rollup. Namely, marking things as external. I'm going to bring that line into our Rollup config. It says, okay, D3 is external. Also, globals. We need that as well under output, so that D3 can be resolved to the right thing at runtime. Since we're using D3 area label as well, this piece also needs to be pulled in from our rollup config. It just says anything that gets imported from the D3 area label package looks to the D3 global, and that just happens to be how that library is set up. It adds more stuff to the D3 global. Okay, and finally we have index.html. Where should we put this? And this is kind of ugly indentation-wise. Let me just fix the formatting. Okay, we're pulling in these 3 libraries from unpackage, and then we're running our bundle.js. But is that where it ends up in our new rollup config? No, it ends up in public/bundle.js. Okay, good to know. That makes a lot of sense. The directory name public is typically where index.html lives, and also CSS, maybe images, or data files, things that get loaded by the client. So I'll go ahead and make a new directory called public, and I'm going to move index.html into public. And you know, that's where the data should live as well. So I'm going to move aggregated data.json into public. There's also styles.css, which can go in public as well. Okay, now public has our data, our HTML, and our CSS. Let's see if our rollup build works. See, our index.html expects a file called bundle.js, and our rollup config outputs a file called bundle.js in public. However, that's not there at the moment. To make that exist, we can look at our scripts in package.json. See, we have a build script, which will just run rollup to generate that bundle. To invoke that, we can say npm run build, like so. And it says unresolved dependencies and also missing global variable name. Okay, we just have to take some more stuff over from our other rollup config from VizHub. Namely, we need to add array blur and D3 area label under the external configuration, like that. Also in globals, we need to define which global array blur resolves to. It just so happens that that library is also set up to add stuff to the D3 global. So we can say array blur resolves to the D3 global. Let's try that again. Okay, no errors. And now bundle.js has been generated in the public directory, and it looks something like this. It's pretty small. This has been minified, by the way, because in the rollup config, Terser is used. Terser is a minifier. Okay, great. Now let's see if everything actually works. There is a script here called start, which just runs serve, which is another npm package, and it serves the public directory. Let's try that. npm start. Okay, we have a local HTTP server running on port 5000. And if I run this, boom, it works. Look at that. Amazing. So the work is done. The final step here is to, commit whatever we've done and make it work with GitHub Pages as well. Also, I'm remembering that I manually copied the data over into the public directory, but ideally our scripts would output there directly from the aggregate step. So instead of writing aggregated data.json, I'm going to change this to /public/aggregated data. This way, if we modify any of these scripts, we can just run it and then push to GitHub, and it'll actually automatically deploy to GitHub Pages with the fresh data. I'm just going to run that processing script one last time to make sure that the last step works. I think it worked, but to be sure, I'm going to delete this file. Now it's gone. I'll run this again. And I'm getting an error now. Scratch that. Okay, that ran. And now in public, that file exists. Boom, all done. Git status to see what changed. Oh, a lot of stuff changed. I'll add everything to Git. This change set looks good. Make front end work is my commit message. Push that up. Okay, now we can go to this GitHub Pages site. Oh, now it shows the README. That's pretty cool. But we can go to /public, and we should get the visualization, and we do. All right, sweet. Ideally, we would not need the /public. But in the settings for GitHub Pages, we can only select between two options, the root and /docs. So the thing to do might be rename public to docs. That way, we could, just use the root of this URL, and that would resolve to the working visualization. So I'll go ahead and do that. I'll move public to be called docs. And then I'll search for all mention of public, which gives us these 3 places that we need to change public to docs. And by the way, I'm using this AG function, which is a really nice thing called the Silver Searcher. It's like a command line search utility. Okay, so in Rollup config, I'll change public to docs. Yeah, that's the one. Same thing in package.json. Public to docs. And lastly, in our aggregate script, public to docs. All right, there we go. I'll add that to Git, make a commit. Migrate public to docs for GitHub Pages. Push that up. Now I can change this setting to use /docs. And now if I go to this URL, it'll take a minute to change. But if I refresh, it should eventually show up. The last sort of loose end we need to wrap up here is the fact that our client program is still pulling in data from GitHub Gist. See, check it out under source index.js. We've got this data URL, which is still pulling from GitHub Gist. This one needs to change to pull it from dot slash aggregated data dot JSON. And this is where, we've moved a bunch of stuff from the front end to the back end, or the pre-processing step. So we're going to have to modify this transform data function so that it does not do all the stuff that it did before. Rather, it's going to expect this new format for our aggregated data, which contains dates and what else? Repositories. So we can destructure those from data. And let's take a look at our aggregate step. It does a bunch of stuff in here. So we can delete that from the front end code. We don't need to do the grouping. We don't need to compute all this stuff. We do, however, want to apply the smoothing. Layers here represents the list of repositories. So we can derive that from repositories by saying object.keys repositories. And all weeks is actually dates. However, we do need to parse those strings into dates using parse date, which we have defined there. So how about this? Instead of doing this destructuring, we can say data.repositories, and we can also say dates equals data.dates.map, a function that takes as input one date and returns parse date of that date. Now dates should be defined correctly, and we should be able to set everything up, just let it run like it did before. However, there's this thing called data by layer. What is that? I think I clobbered its instantiation. We can use git diff to figure that out. Yeah, here it is. I deleted it by accident. It's just a new map. So we can bring that back right here. Data by layer, new map. And now let's see if it works. So npm start just serves everything. What we want to do now is actually regenerate the bundle. So let's try this dev script, npm run dev, that will run in parallel both the start script and the watch script. And the watch script is essentially the same as the build script, but it watches, meaning every time you change a file, it automatically regenerates bundle.js. So I'll shut down npm start and run npm run dev. Oh, look at that. We have some warnings. That's really nice. Unused external imports. UTC week, UTC weeks, and group are imported but never used. Yeah, that makes a lot of sense. So we can just get rid of those. We don't need UCT week, UCT weeks, or group. Great. See, I wrote that file, and then it updated bundle immediately, automatically. Let's see if the front end works. I believe it was localhost 5000. It appears broken. It says grouped data is not defined. Okay, let's see what is that? I think what used to be called grouped data is now called something else, but no, that's actually not the case. what we have is layer data. Yeah, I remember. This stuff is actually in our data processing script in the aggregate step. Yeah, so what we're doing is we're saving layer data to the file. So we can just get layer data out of the file by saying data.repositories at layer, like that. Okay, let's see if that worked. All weeks is not defined. Yeah, I think we changed that to be called dates. T is not an iterable. Okay, it says T is not an iterable, and if we follow the code, it's when it tries to compute extent of data. Apparently data is not an iterable. So let's see, we just need to connect the dots. Data, I believe, was the original data. So we actually need to change the front-end code so that it doesn't need data at all. All it really needs that for is to compute the domain of the X scale, which is the extent of the dates. And we have those dates available, so we can just expose these dates instead of data, and then we can use that to compute the extent. It's just going to be the extent of the dates. And it sort of worked. Got something kind of funky going on. I don't know why the dates go back to 1970. It appears that we might have like an invalid date. Yeah, the dates are going back to like 1971. Why is that? Okay, well that's what's appearing in our aggregated data. So why is that? Looks like there's some bug in our data processing scripts. Oh, here it is. It's allweeks.map. That should be... Well, no, that looks fine. Format date of date. It should just format all the dates. Let's console.log all weeks at index 0 to see what is the first date here. It says 2013. That seems right. So what's going wrong here? What if we pass that into format date? It says 1969, 12/27. Why? Okay, this is super weird. If I just bring back the code like this, it gets the correct date and the stream graph appears correctly. Okay, weird. But we seem to be missing a bunch of commits on D3. Okay, the issue there was it was calling exec, and this command was not finishing before the next step in the pipeline ran. That's why we were missing some commits. So I just changed it to be exec sync. So this command actually totally finishes before the next one runs. And that was the source of our strange errors. So now if we run this and we load the data into the viz, it is full and complete and has all our stuff in it. The last thing I want to do to really set up this project is to adopt Prettier. Prettier is an automatic code formatter, and I personally can't live without it. in our code so far, there's a lot of inconsistencies, like different kinds of quotes. Sometimes we use semicolons, sometimes we don't. And if we just run Prettier across this code, it'll fix up all this formatting stuff. Let's install Prettier. I'll just follow these steps here. Run this command. This will save Prettier as a dev dependency in our package.json. And then we create a .prettierrc.json file. This is the configuration for Prettier. And then we create a Prettier ignore file. And it looks like we can just use our git ignore as the same thing. So I'll create a file, Prettier ignore, and I will read in the content of .gitignore. Save this file. And then we can run it like this. I think this will work. npx prettier --write. Okay, that looks amazing. Wow, we formatted our HTML, our CSS, all of our JavaScript, even our JSON, and our Markdown. Imagine that. If we see the diff, we can see what changed. See, now it's consistent use of double quotes, all this different stuff. I personally prefer single quotes, so we can configure that by just adding single quote true to our .prettierrc file. In our prettierrc file, I'll just add that. Single quote is true. And then we can run Prettier again, like this. Oh, I'm noticing it's running it over our bundle, which is not required because that's a minified generated file. So I'll add that to our Prettier ignore. Okay, that should do it. I'll make a commit. Adopt Prettier. Git push. And I like to have Prettier actually as a script in package.json. So we can just make another entry here called Prettier. And I believe that could just be Prettier --write dot. I think that'll work. Let's try npm run Prettier. Okay, that seems to work. Add Prettier script as a new commit. And we're done with the setup. All right. All right, now we've got a pretty solid open source product. All right, that's how you can productize a code base.